half the years I teach it as ln to solve, and the other half I teach it as log. Here's what they actually mean.
Natural log.
Exactly. So we're going to say that if y equals 10 to the x, what's the inverse of that? What's the inverse of that? Think what inverse means. What does inverse mean? Please?
X equals 10 to the y.
Yeah, so x equals 10 to the y, right? Okay. So what happened? They came up with something called log that will. So basically, log 10 equals 1. That's what basically the thing is. Okay, so that's how the inverse of that goes. Now, this is how ln works. You don't write this down, it's open in your final exam. Ln is called the natural logarithm. E is a number like pi. It's 2.71 ... forever and ever and ever. Okay. The inverse of this as well is y x equals e to the y. So it's going to be ln x equals ln e times y. So ln x. So we're going to say ln e. Okay. So all that means to you guys, don't worry about it. You don't have to know this until grade 12, okay? But all this means for you is it does the same thing. Ln and ln both bring stuff from the power to the base. And as long as you use an equivalent thing for both sides, they cancel out, okay? So you can use either one. So I apologize not for telling you that. That'll help you. If you want to use log all the time, you can do it. If you want to use ln all the time, you can do it.
What if you use both of them the same way?
As long as they're consistent in the same equation. Like you can't do this, like log 3 over ln 4, you can't do.
Why not if they're the same?
Well, they're the same being that they both have the same function, but they don't have the same output, okay? They have to be relative to each other, right? So these aren't, they have the same function that they bring the powers down from the exponent to the base, okay, right? But they don't actually have the same value. What log is based on everything being base 10, being that, like 10, hundreds, thousands, millions, but ln e is based on everything being exponent e, and you'll talk about that more in grade 12.
Wait, so we can only use log when it's like 10 hundred?
No. But all I'm saying here is though, if I say like log, this is how logs come from. If I say log of 100, that equals 2. So that's how logs actually work, okay?
Why? If you do ln 10,
yeah, I know. Okay, because it doesn't work out the same way. Okay, so it's going to be log, because basically you have to change everything to e to the something. Well, the thing is, what happens is it's when everything base e. Okay, so don't worry about it. All I'm saying is for us, you can use either one as long as you're consistent all the way through. For these, you can talk about log, we will continue to use log. Okay, right, but the math, it doesn't actually affect your answer. So let's go to our warm-ups here, and then we'll get going here. So today's November the 2nd, 2015. A is 200 equals 10 times 2 to the x. Okay. Now, Matt, I'm going to embarrass you since you were asking good questions. Hello. On the way through, can you do the first step here to solve for x? Right on. Okay. And this, everyone should hopefully have this one right. Okay, so it's going to be divided by 10, divided by 10. Can someone other than Matt explain to the class, what's that, 20, is that right? Can someone other than Matt explain to the class why that actually had to happen? Let's go ahead.
Because we only want like base and then like
Right on, okay. So it has to just be like one, like a base and an x, or a base and a variable, and that equals a number. That's the only way logarithms work to solve it.
So when are we going to get it?
Soon. That's what I'm going to say. Okay, then you guys are now next on my list. I have a list of, you know what I mean, the way I mark things. You guys are next on the list. So hopefully about 99% tomorrow. Okay, right? I'm going to leave my 1% out of the chance. Okay, but it should be tomorrow. Okay, can somebody tell me what to do next here, please? How about Julia? Put away your phone and give me the answer here, please. Go ahead.
You do log 20
Yeah.
over log 2.
Yeah, and I'm going to show this step, but you don't have to. Okay, so it's going to be log 20 over log 2 equals x. Okay, awesome. Is that number by any chance? Uh-oh. 4.3 to that? Okay. Now, how can I tell that's right? Well, this is how I can tell it's right. 2, 4, 8, 16. 2 to the 4 is 16. 2 to the 5 is 32, so it's got to be between 4 and 5. Right? That's why in my head can tell that number sounds good. Okay, are we okay before I continue to move on from here? This is from Thursday last week. Good? The class hasn't even started. Go. Here we go. B.
No?
Yes, go. Hurry up and be fast. I want you back in for C at the end. 1, 2, 3, 4 equals 4.5 times 1.3. Okay, this is the very same question as A. Okay, the only difference is there's decimals and it looks messier. Canos, first step, please. Great. A little bit slower here. Go ahead, 270. Oh, sorry. Thank you. And I hope, and again, I've been mean to you guys here, okay, right? But I hope we were learning that again. You always do after your first step. The way I want to make that a big deal because people tend to forget.
I didn't do anything.
Can you be brave, please? Why do you ever think I'm yelling at them?
Okay. I have a question.
Yes, go ahead.
What, can't stop laughing at me.
Go ahead.
So what I do, yeah, I was just kind of confused because it has x plus 1, and I still do log there.
Yes, the variable I'm going to deal with at the end. The same thing happens. So, and this is the same idea of Friday's lesson, right? There was like fractions and stuff in the exponent, right? That's what happened on Friday, if you remember back. All right, but otherwise it should all be the same. The only difference was, unfortunately, I wrote ln here instead of log, but otherwise it was the very same math that happened there. All right, Lexi, next step, please. What? Yeah. Okay. Very good. I'm just going to keep the x plus 1 on the right, but you can work on the left as well. Okay. So now remember in the numerator, for Alistair and everyone else, it's got to be as many 2's as can fit in your calculator, right? Or leave the fraction. Okay, Alistair, can you give me that number, please? 21.397 dot equals x plus 1. Can someone confirm that for me? Everyone else got that? Okay, great. Nathan, last step is? Good. So I'll call that 20.397. Okay, now before I move on to Friday's lesson, which is what we're getting into, any questions? Chris?
For log 274.222, does it matter how many decimal places that you put?
Yes, you want to leave exact, like as many as humanly possible. Okay, right? Like you never ever want to round. Remember from math until the very, very last step. You never ever never want to round if you can. If you can leave that as a fraction, like I could probably log bracket this if you want to. You don't need to keep this exact as possible.
Wait, so in our answer, we can have all the decimals?
Yeah. Or at least
So, like,
give me like 2 or 3 and then do dot dot dot, meaning that you continues on, right? You know what I mean? That not that like it's not 777, but that it you just got lazy and didn't want to write it all 10 digits.
It's just that when I just did 2 decimal places, so it's just 274.22, I got 20.93.
Yeah, and it'll make a big difference, right? Yeah, it makes a huge difference, right? So be as exact as you can here, please. Okay, beyond Chris's question, which is a good question. Okay, because we'll get into in our money unit, yet it's the same thing. You can never ever round in your life. Are we feeling sort of good about A and B before I move on here? Okay, now C is like yesterday, so it's the word problem part. Okay, so this is just the math part of Halflife, is what letter C was. All right, that's why I put this in here. So, James, I'm going to start with change it to 500, right? 20 equals 500. Bracket 0.5. Let's say n over 20. James, can you give me the first step here, please?
20 divided by 700.
Wonderful. You know, I don't want to brag with you guys, but I'm going to brag. You guys are probably the best at this. What does that equal? 0.04? The calculation part of this from any other class I've ever had. The number of people that screw up that first step in my rest of my classes is tremendous, okay? So please make sure when you do that, if there's somebody who keeps forgetting that, don't be that person, okay, right? But that first step you need to do. Yeah, go ahead.
Why wouldn't you take it as a fraction of 10 over 20?
If you want to use a fraction, Zach, go ahead. Okay, right? If you want to, so the question was, Can I leave this as a fraction? Always yes. You always can. Okay, just as hard to log the fraction. Do you calculator? No. Okay, so. All right, Taylor, what do I do next now, please?
Can you do like the thing where you move something so it's not funny?
Not yet. Somebody help her, almost. Somebody help her. What do we do here? Well, yeah, we're gonna log everything, right? We'll do something with the 20 in a sec, okay? But this is the same. Now, if you prefer ln, because it's the new way, do it. But we're gonna leave that n over 20 in brackets, right? Because that, you know what I mean? The exponent comes down, that's what a log does, right? Or an ln. All right, Owen, next step here, please, is what? Good. So it's going to be log of 0.04 all over log of 0.5 equals n over 20. Okay, so you see what I did there? It's the same thing we did before with the x plus 1, right? It's just whatever's in the bracket is by itself. Natasha, can you do log of that divided by log of that and tell me what you get, please?
Is 4.644.
Okay, can somebody confirm this before I move on? Now, if I don't trust you. Just confirm. Okay. Thomas, pretend this was regular algebra class, and you have n divided by 20. How do you get rid of the divided by 20? What do we do? By 20, good. So it's going to be 20 times all of this. I can't do in my head. I probably could, but I don't want to. What is that? 92.87. 92.87, dot, dot. Okay, now I'm going to do one question involving Halflife, okay? Because that's basically the 88. No. 92.88. It's close anyway. I trust you that you're close. Yeah, I'm assuming. Yeah, I don't know what's going on. I'll call it 92.88 and we'll call it. I'd say exactly 92.9. I rounded it to one decimal. We're all happy now? We're at one decimal, we're all happy. Good? I don't want to call it. What's that? That's true, but if you're in science class, you have to estimate, okay, and that's what these are, it's a science class, okay?
Wait, but do you want us to round?
In the final answer, I will say around to one decimal place wherever I say, okay? So I will say, if I tell you, if I tell you to do something, do it. If I don't, you can't read my mind, so you can do either one, okay? Right? It's not fair for you to say you didn't say, like, it's not like I expect you to do something, you know, if I don't tell you, then you can't read my mind, right?
Okay.
So. All right, here we go, Halflife. No, this is yes, this is Fridays. All right, so I don't say it's Halflife bracket. Yes, you want to memorize this equation. Okay, can someone recite from memory what the Halflife equation is for Fridays? I don't have their notes open. I'll take it right now. Sorry, go ahead. Right, I'm going to call it 0.5, but 1/2 works as well. Okay, either one, we mean the same thing. Now, before I go on here, let's talk about what Half-Life's all about. I hope you got this from Friday. Other than being a wicked video game from the 90s, what else is Half-Life? Yes, go ahead. Right, the amount of time it takes for half of something to decay. So something about Half-Life would be like the hair on Mr. Sadler's head. Okay, right? So after, you know, when I was 20 years old, I had 100,000 hairs in my head. When I was 30 years old, I was down to 50,000 hairs in my head. That's a joke. When I'm down to 40, here's the thing though. Here's how Half-Life works in one sec. If I go 100,000 hairs, oh boy, at age 20, then we're going to 50,000 at age 30. Now I want you to actually take this down because it's important concept of Half-Life. How many hairs am I going to have at age 40?
25,000.
25,000, not 0. Okay? Now how did you get that? All right.
I divided it by 2.
Divided by 2 or times by 1/2. Okay? So you're just chopping in half every single time.
So I have a question about the coffee question. The substitute told us that eventually the coffee would leave our system. But does it
Mathematically, it doesn't. Mathematically, there's going to be something left in here. Okay? So in like, and that's what they say. Whatever you consume, as far as drugs and stuff like that, like if you take any medicine, it will always be microscopic amounts still left in your body. Okay, so just someone else other than I. If I get to be 50 years old, how much hair will I go up to my head? Please, be kind. Chris, go ahead.
One, not very much. 17,500.
Close.
12.
Oh,
Okay, so Chris miscounted that in his head, but how'd you get that? Whoever said that?
I said nothing.
Divide by 2 again. Right, that's the idea. So I'm going to word this on your test. I'm going to write it like this. Will Mr. Salad ever be completely bald? Justify your answer. Will this be kind? Please be kind. Will this ever get to 0?
No.
No.
Always something.
No, we will always have something left, even if it's microscopic and a decimal, okay? So what will happen is here, right, it'll keep chopping again and again and again and again and again. Mathematically, you'll never get to 0. Okay, right? It'll get very, very small. Because, again, this is the whole thing with that piece of paper thing. You know, they said you can only fold the paper 7 times, right? If you had a paper so big you could keep ripping, you would always still have a little piece. Would it ever get down to nothing? Well, no, you could, you know what I mean? Keep ripping as small as possible then, right? Who had a question as I start, Taylor? Go ahead.
So if you're 100, your half-life is 50.
No, not really. You don't want to get into,
So why?
you don't want to really get into that. Half-life is just sort of basically saying the amount of time for half something to go away. That's all it is, right? So, yeah. I don't want to get into people because it doesn't really work that way. Yeah, it's not really life. Yeah. Yeah. Because it's not like, it's not, cause,
Divide by 2.
right, that's true.
Like if you died at 100 years old, then your half-life would have been 50.
I don't want to go
You
there.
don't
I
have
don't want to go
constant
there.
rate.
Yeah, I don't want to go there because you're talking about like rate of change. That's what you're thinking of. I don't really want to go down that road if I can prevent it right now. Okay. Let's get to what all these things mean. C equals the starting value. M equals the ending value. T equals time. And H equals the length of one half-life. Okay, I'll get this away here. You may have heard this in biology class. Ryan, you with us here? Okay, you may have heard this in biology class. Okay, you will need to know those 4 things. So starting goes with the decimal. Now the other thing to think of, the bigger number has to go with this because it's being chopped in half, right? So just like this equation, the bigger number has to go with your whatever, 0.5. Okay, let's do one question with math, one word problem, then I'll move on. What I will do for you guys, because I'm a kind person, is I will probably give you one half-life warm-up every single day. So we can talk about it a little bit every morning, okay, so that you guys can feel good. Okay, here we go, example 1. Bacterium has a what's a new element? Has a half-life of 8 seconds. If we'll say 41 kilograms were produced, A, make a table. B, how much is left? After 1 minute, and C, we'll say when is 14 kilograms left. Okay, this is a test question without the part A. The part A I want to do just, I'm going to get out of the way here. The part A I'm going to include just to talk about it for a sec, okay? But on your test, it'll just be B and C. It'll say how much is left after 1 minute, so if you can't read, that's the question. What am I printing? You sure?
Get your back to it.
No, not at all, thank you. I went to physio this morning again, and I spoke, sorry, not I, a teacher in the staff room spilled my coffee, so I got down on my hands and knees and scrubbed. Let me tell you, doesn't work, okay? The first word, bacterium. It's a brand new elemental an element I made up here. So it's the last name of Carly with anything else like there's an Einsteinium? Haven't you heard about an Einsteinium?
Lorenzi.
See, there's all sorts of weird things. There's all sorts of weird things. So Saglarium will probably, we'll find ones then. All right, so a half-life of 8 seconds. What does that mean for a half-life of 8 seconds?
Then in 8 seconds, half it'll be gone.
8 seconds, half it's gone. Okay, so this is quick. You make the stuff and it's gone almost instantly. Okay, so we have made 41 kilograms in real life. Okay, so we
16 seconds is just false thing.
no. This is the thing, just to make sure. After 8 seconds, half it's gone. After 16 seconds, how much is gone?
3/4.
3/4 is gone, right? Because half of a half of a half, and this is where the table comes in. Okay, so I'm gonna make my table for part A, which is called time.
So it's not actually half.
No, sorry. It is called a half-life, right? But it's never actually going to disappear, though, right? So if you think, and this is what you hear on the news. I remember when I was a kid. Yes. Now, yeah, no, I remember this as a kid. And I'm sorry if I don't hear when I hit pause so I don't get fired. But I heard on the news when I was a kid about Bruce Power. On to this time and mass thing. At time 0, how much mass does bacterium have? 41. After 8 seconds. Now, how did I get 8 for my next entry? Why did I put 8 there?
That's the half.
That's already half-life, okay? How much mass is going to be left? 20.5. Okay, so I just want to make sure before I continue that everyone understands where that came from. Where that 20.5 came from. We're all good? Just dividing by 2 and multiplying by a half, all right? Now, here's the thing with this chart. I'm going to go through this chart until I get down to 1 minute. What's 1 minute in seconds, please? 60. So I'm going to go until 60 seconds. What this table is used for is to give me an eyeball to make sure that I have a reasonable answer, okay? And if there's an entry right on here, so 16 seconds, you guys are going to need to help me here, is, 10.25. 24 is 5.125. Oh boy, this is getting tricky now. 32 is 5625? I should use smaller numbers. 1.28125. 0.64. Oh boy.
How do you do this in your head?
I'm a math teacher. This is what I do for a living. It's like, how do you catch a rugby ball? I don't know how to catch a rugby ball.
Why are you doing it by intervals of 8?
I think that's right. Okay. Okay, good question. Now, just so Carly understands here. I don't know what that last one. I was starting to tell jokes about catching a rugby ball. I'm good at catching a rugby ball, by the way. Okay, right? But just let me check that last number for me because I don't know about that one. That's good. Okay. Now the question was, and Carly asked, this is good. This is the important part. This is why this table is here. Why do I keep using 8? The half-life. Every 8 seconds, Carly, things are cut in half. Okay, so every 8 seconds you have half of what was there previously. All right? Okay. That's all right. We're good for the numbers. Somebody computed that for me, I hope. Yes? I think that bottom, it's not really important, the bottom one, okay? Now, as far as what the answer that we're looking for here, sorry, I'll give a second to copy. Grab my water.
I have a question. Is that a 2 or a 7? At the very bottom.
160156125 is supposed to be. Yes.
What should I do when you use the 56 or the 64?
Neither. This is the thing. So I'm going to go through part 1. If it says how much is left after 1 minute, what's the time going to be for that? 60. So that means my answer here is going to be here, which means that my answer for that I should have for mass is going to be around 0.2-ish. Okay, right? It's going to be between 0.16 and 0.32.
So you just want us to guess?
No, we're not going to calculate exactly what we're going to do. Okay, but this table is going to help you to guide. If you do figure this out and you say the answer is equal to 58, we'll know that we're not even close, right? Like the answer, and this is what the chart does. The answer is going to give us an answer between 0.16 and between 0.32. On the second one, it says, when is 14 kilograms left? Well, it looks like the answer's in here for 14 kilograms, so it should be between 8 and 16 seconds, right, for part B. Okay, so all the chart does, it sort of gives us a plan of what our answer should be, because this is really calculator heavy, right? And if you type in the wrong number, it's very, very easy to get the answer mixed up. Okay, are we ready? Are we set? Let's good go, as I tell my daughter as she goes down the slide. Here we go. So after this here, so B is 1 minute here. So I'm going to say M equals C equals T equals H equals. And Carly, since you're the star of the show today, I would like you to, in a loud, clear voice, recite the equation from memory, please, in a loud, clear voice. Right, I can read it off the page.
N equals C 0.5.
Yeah. Good. Yeah, I'm not doing that to humiliate Carly, but the best way to memorize things is to hear them, say them, and write them. Those are the best ways. So by hearing them, saying them out loud, that'll be good. Okay? All right, Emily, can you give me anything that I know about this question? The M, the C, the T, or the H, please.
You know, C?
Yeah, C is 41. Good. Because this is your starting value, right? That's 41. Cassidy, is there anything else I know for this question, please? Time is? How much? Yeah, H is 8. H is 8 seconds. Good. Chris, go ahead.
60.
Yeah, 60 is fine. Very good. Okay, and then, now, someone's going to ask me, they're going to say, do I need to write that stuff on the left? 100% yes. Okay, because very, very soon we're going to do things where there's like multiple things we have to solve for. Okay, right? So get in the form. Your teacher will be happy in math. Your teacher in physics will also be happy. And all of your future teachers will be happy if you get in this form. Okay? Okay. Cecilia, can you sub some numbers in for me, please? Go ahead.
M equals 41.
Yeah.
Times 0.5, 60.
Great. And then that's just calculator work. If I was doing this as a student, I would probably do this if you can't do it all at once. That's what I would do. If you have a super calculator that can do it all in one step, you do it all in one step. Chris, go ahead. RE and everyone else. Now, I don't see about 3 people typing in their calculators. You guys should all have your calculator ready for me, please. It's not up to me to get this answer. Do you want to worry about the calculator? Oh, I can't believe someone throw that. I'll never throw a calculator. No, great.
You don't, you just like solve it out because of the one side whole number. There's no there.
Actually, you don't bring.
No, you don't have to bring everything over because it's just M equals, right? All right, so, RA, we're able to get an answer,
I
please.
got 0.226.
I'm assuming there's more dots after that. Now, looking at RA's answer, am I satisfied with that?
Yes.
Why?
No.
Why look at 0.226 when I feel okay with that? Go ahead. Yeah, looking at this without even checking, I'm assuming it can work the calculator. But also, it's in this range, right? That's the whole idea, right, of being the table. Yeah, so definitely, so therefore, after 1 minute, there is 0.226. Does Mr. Curry or whoever teaches chemistry, Mr. Ward, not give you cool things that you make up and it like just disappears in front of you?
No.
Oh, Mr. Solinger would do that, I bet, totally. Yes, go ahead. Okay? Sorry? What'd you get? C times 41. Let's try one more time. So this has to be 0.5 to the power bracket 60 divided by 8, right? You need brackets here. Oh, did you get this? Oh, you're giving me money for a student card. Oh, and I love it. Oh, and I can spot your 5. No, I'm just joking. I can't. Oh. I can't. I don't have any money. I'm sorry. You know, I just got paid on Friday. What's that? It's just 30. Are you good now? Yeah, it is 30. It's 30. I think it's 30. It's 30, I think. Now, eat lunch, so I don't want this to start you that you don't get to eat lunch because you're paying their student fees.
No.
Oh, ahead of lunch? Oh, Lexi, you're cruel. Okay. As far as letter C here goes now, let's finish this one up and then we'll go on to today's lesson, which is a nice lesson. I'm going to write again here, M equals, C equals, T equals, H equals. Luke. Yeah.
So this one, like the very what you're defined is one of the exponents.
Right on.
Can you do like a lot?
Yes. Okay, Luke, in a nice, can we go place? Luke, in a nice clear voice, can you give me the equation in English, please?
C.
Yeah.
Back 0.5 back T over 8.
Great. All right. M equals C is 0.5 T over H. All right. can you give me one piece of information, please? That I know for this part C. Give me any of that? No?
Yeah.
Go ahead.
So like the kilograms, 14.
Okay, so which one's kilograms going to be then?
Just
M is going to be 14, good. Robert, can you give me something else, please, for this one, if you can?
Mr. Sadler, Emma's my sister.
It's the first time I've done this last. I did this last year too, didn't I?
Yeah.
Once, did I do a lot? It's the first time this year though, wasn't it?
Yeah. Yeah.
Well, how's that way?
Robert. H is 8 again, good. Okay, so I better somebody else so you don't feel bad. All right, Frank, what's the next answer then? Okay. No, go ahead. What's the next one, please? What else do I know?
What was the question?
This is C. So this is, we're going back to this one. Whoops. We're going back to this one. When is 14 kilograms left? Okay. Yeah, C is something. What's your starting mass here for this? Somebody help me. What's the starting mass? 41. 41 is your starting mass. Okay,
I'll always just take 41.
well, okay, generally what's going to happen for this is that I'm, like these two I'll give to you, C and H I'll give you for the starting part, and then in one equation I'll solve for M, the other one I'll solve for T. Right, okay. All right, great, wonderful, excellent. Rachel, can you sub some numbers in for me, please? Go ahead.
Equals 41 bracket 0.5 and bracket t divided by.
Great, and you said M equals, but I'll call that 14 equals. Okay, that's okay. Yeah, good. Lauren, be brave and give me the next step, please.
T divided by 14 by
Good. Now, I want everyone to try this, okay? Because this is very much like at this stage, the third warm-up we did here, right? It's the exact same question, right? Except there's going to be decimals and all that stuff, okay? So 14 divided by 41 is sort of like this. Oops, that should be 41.
Yeah, no, right?
14 over 41 is a metric decimal. I can't even do that, 0.3 something.
2.341, of course.
Okay. All right, Min Chen, I have this right here I have to solve for T. What's the next step, please?
You have to do laws
Right, I'm gonna write in 2 steps. You're exactly right. Again, if you want to do LN, and I apologize that about Friday. One other thing I just want to say, if where are we here? If you just want to go from here to that line, I can live with that. I have no issue with that. Chris, can you do log of 0.3414 dot 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 divided by log of 0.5, please?
1.5505.
All right, Lindsay, I have T divided by 8. How do you get it divided by 8? Good. I can't do that in my head. Can you count up by 8 for me, please? 12 or 13 or something? 12.40. Now, before I continue, I know this is fast and furious, okay? Looking back to my chart, I was hoping the answer would be between 8 and 16 seconds, right? Which it is, 12.4. Okay? So that means that we're feeling okay about that. That's what the chart's good for. Therefore, after 12.40 seconds, what do we have? 14 kilograms is left. Okay. This is a type of question I want you guys to ace on next Tuesday, which I haven't actually announced yet, but Tuesday will be the test. 30.